Hello, so I wrote another little program tonight. This one is to demonstrate, um, reading and writing the registers and comparing the data to, it would be like if you were doing a functional test and you wanted to compare data. And what I do here is I'm masking bits. I'm masking bits. I can show you what I'm doing, which I will. It'll be very quick. I'll just give you the whole program. It's actually pretty neat. But there's nothing in this case. This is just a while loop is continually running until I press stop. This is a case structure as a false. Here's the true case. When I press, either one of these buttons, it runs this true case and it starts the test. These are just address. These would be, memory registers that I'm reading. It'd be like a status register, alarm registers, whatever. And I'm selecting, which one of these I want, with this selection. This is reading a file, and this is like the beginning and the end of a section. This is the beginning and end of a section. This is the beginning and the end of a section, and all these sections are going to have one of these values for registers. Which register I'm looking at, and it'll have other information in there like what I'd be writing, or what kind of data I would be expecting. Like this right here is data I'd be expecting in binary. I'm putting X's in here to mask bits. It's a don't care bit. I'll show you how I'm doing that on the next screen. It's right here. Actually, it's right here. So with this, there's like it's base 16. It's 0 to 15. As you see, the binaries bits are counting down. So that would be zero and zero all the way to 15, which is all ones. F is all ones, and zero, keeps going down all the way to zero. And it just compares every hexadecimal character, and then it goes with hexadecimal, and it compares the binary bits themselves right here. That if it sees an X, it just ignores the comparison. It could be a 1 or a 0, it ignores it. If it sees an X, it goes ahead and sends a true here and an OR gate, either one of these. If either input's true, then the output's going to be true. It doesn't matter what this one is. So then it just puts those 4 bits in and it puts all 32 bits together eventually on the output, but it does 4 bits at a time, and the output will be 32 bits. Um, this this is how I'm indexing through the expected data. I take the first 4 bits. And I'm just going through all 4 bits each time and running them through here. Then I go into here. This is where I'm just displaying information. Um, I have to get it in the right format. I have to reverse the array. I have to do what I need to do to make sure that all the data gets into this display correctly. That's all I'm doing is putting the display correctly. The binary bits goes into here, and the rest of this is display information. You'll see that in a second. This is the address, which is coming from up here. It's the address. You'll see that in a second. It's actually pretty neat, but I'll show it to you. I mean, if you were to use something like this, you wouldn't want most of this stuff up here. You wouldn't. This would be what you'd be using, and still, it's this is just like I just made this over the last, I don't know, 8 or 9 hours. I wrote this over the last 8 or 9 hours just for something to do. It's like almost midnight, February 27th, 2025, and you still won't tell the truth for me to get a job, you crooked cops. Anyway, like I said, this is reading from a file. This is the file over. I closed it. Let's go get that file. It's right here. There's the files. Like I said, these are just little sections. I read and I grab the data inside here. You'll see that when I look for alarm, it has that data. That has that data. These are the data that I'm actually writing. What this would be is you would write a script to a board, and then you would want to check the board to see if the board was working. They would have you'd have status registers and alarm registers you'd have to look at, and you would check to see if the values were correct. That's what this would be. These would be the actual values you're looking for, um, and this is what I'm doing. I'm simulating that I'm reading this back from a processor. That's all I'm doing. And I'm comparing this data with this data. And I know all these pass. I know that because I've checked the bits. I know it's going to work. These I'm injecting in an alarm. And you can see, I'll just give an example. This, I already know this is where I'm injecting it is A. And I know that's A right there. That's where I'm injecting the error is right here, E. I'm writing an E instead of an A. And E would be a 1110. And since it's not an X, it'll give an alarm because it has a 1 there instead of a 0. So that's just a demonstration of what I mean. Another one would be this one, 823. It's 223. So it'd be uh, it'd be this one right here. I'm writing an 8 instead of a 2, so it'd be a bit it'd be a 1000, and now this one would matter because the X. The problem is this will be a 0. That's the problem. So and that's why we're giving an alarm on that bit. Now that I've shown you that, I'm going to show you it works. Just so you can see it work. Go ahead and run it, and this will be really quick. I'll just go ahead and run one test. You can see that works. And I'll go ahead and run the second one. Down where you see all the bits changing, go to this one, and all the bits changing. Now again, when I'm injecting an error, you got to remember that um, I've already selected where I'm going to inject the error. The error the alarm would just show up anywhere if there was a real alarm somewhere. This one is bit 9. You can see it's actually bit 9. This is the mask data because you can see the X's. So what I'm looking for is a 1, and what I got was a 0. And if I just run the normal test, you'll see if it's a 1, it passes. Now we'll go to another one, and I'll run this one. And bit 16 and 17 have an error. You can see that it's supposed to be zeros and they're a 1. And if I run this, just a normal test, you'll see they go to 0 and it works. Let's go to this one over here. This one will give a better example. This will give you a better example, I think, because you can look and it's a 1101, and I have all ones. That for the alarm, it's for 22. If I run the normal test, it's a 0. It's a 0. But like I said, this is the one that had the 8. This is the one 1000. And you see the problem is actually the 0, not the 1. If I run the normal test, you'll see I wrote a 2. And when I injected an error, I wrote an 8, which threw a 0 right here. That was the actual problem. Was putting a 0 where a 1 was supposed to be. Anyway, that's just a little demonstration of how to read and write registers. If this would be actually what you would be having on a screen. The rest of this stuff is just for me to test. I mean, when you run the test, it would come back and have this pop up, and it would tell you what kind of errors you would have, and this other stuff you wouldn't normally have it. But that's just a little demonstration of how to mask bits and check data that would be coming from an alarm register. And again, this is binary data, so I'm actually checking a bunch of ones and zeros. Like that number would be a 1. This would be an F. That'd be an F. That would be a 5. I mean, it in hexadecimal. So you can see it right here. You can see it right there. Anyway, have a good day.